Wait. No, that's not what I want to do. That's fine. I'm just handing out my solution. I'm going to go over it, but
Thank you.
so I guess this was more code than you've written before in terms of the homework that was due for today. How long did it take you guys to do it?
An
Hour?
30 minutes.
30 minutes. Okay, so we're going to make them harder so that Nick doesn't get bored. You know, he's going to get into trouble only doing homework for half an hour, so I'm just kidding. That's great, okay? And, of course, the great part about doing these assignments are you know if you got it right because you can go and put more cases in. So, okay, so let's take a look at my solution. For the first one, we're writing a quiz to see if people can raise a number to a particular power. So it's not required, but typically in programming we initialize being setting a variable to its initial value at the top of a program. So I know that I'm going to need to have a variable to hold the number of correct answers and the number of incorrect answers. And I'm going to want to, when I write the code, I know that I'm going to have a while loop to go through the number of problems that we're going to give them. So I'm going to create a variable called count. And so the first thing I want to do is I want to now prompt the user for how many problems they want to do. So I'm going to give them a prompt. And as we learned in class last time, we know that we can validate a value. And so here I think I said you had to make sure they put in a positive number, actually a number greater than 0. And so we can validate that by using the while statement as a validation mechanism. We're not doing, it's not like we're telling while validation, do validation. It's just the way we set up while, and we're testing to see that the number of problems, n problems, if it's less than 1, meaning it's 0 or -1 or -2, then what we want to do is we want to, here I had a separate error message saying error, n problems is invalid. In class I only did it in one statement, but hopefully you saw that you could have had first an error message and then subsequent to that I'm going to put in the same prompt that I had here, and whatever they put in is now going to go back and be revalidated here in this test, and they won't be able to exit this code until they have put in a number that's greater than 0. And I could have incorporated the error statement in this input statement here. Now, once that I know that n problems is going to be greater than 0, now I'm going to want to repeat this a number of times. And so that says to me when I want to repeat a section of code a number of times, I'm going to use while again, so another use of while. And now what I'm going to do is I'm going to repeat these statements for the number of times that they ask me, which is reflected in the variable n problems. And so the stuff I want to repeat is I want to prompt the user for the number they want to raise to a power, I'm going to prompt them for what they want to raise it to, and then I'm going to ask them what their answer is. I'm going to store that in these three variables, and then I'm going to now test to see if the answer is equal to, now I didn't create another variable, I could have, but I'm simply testing to see if the answer they gave is equal to the number raised to a power. You had to put 2 stars in here to raise a value to a power, to an exponent. And if that's true, then I'm going to increase the variable correct by 1 and say you got it. If this were false, I'm going to increase the variable of the value of the variable incorrect by 1 and print out incorrect, and then print out what the right answer was. So sort of in sections here, I prompt the user for a value, I check to see if it's correct, and then after I've done all the work, now I want to increase my counter, the variable count, by 1 and see, and then because this is the last statement in the do while loop, in the while loop it's going to go back and check to see if count's less than n problems. And if it is, I'm going to do this again and again and again, and ultimately once it's greater than n problems, it's going to fall out. I'm going to print out a summary. Note that this statement is not indented, so this is the statement that gets executed after the while falls out, and I'm going to print out the summary. Any, oh.
So I just get the correct number out of like the number of problems.
You did not. You called me. Oh, man. Got to fix it. Okay, you didn't. You're okay. Any questions on that? Anybody do it markedly differently? There's not really much other way to do it, I don't think. Okay, so then the next part was really just taking this and validating that the power that they're raising it to is greater than or equal to 0 and less than or equal to 50. So, much as I hate sort of teaching things as cookie cutter, it seems like there's a cookie cutter issue here. It's asking you to do validation, right? It's asking you to validate that power is less than, greater than 0 and less than 50, right? And so, well, how would I change this code? So now note here, everybody, did anybody try using an if statement? You did. So you did, Dan, right?
Yeah.
So Dan, you said if power was what, less than or less than 0, or power was greater than 50, you then say, you might have had a print statement, you might have said something like invalid power. Sounds weird, but I don't want to type anymore. You had something like that?
I did mine the opposite way, but generally.
And then you said, and then you had them re-enter the value?
Well, I did it if power is greater than 0 or power is less than or equal to 50, and then just go through like the basic stuff, and else is error, the error message.
And then you re-prompted them to put in the right value?
Yeah.
So Dan, so if you had this, So, Dan, you see the problem with this, why the if is not as good as the while? The problem with yours is, if you run your program and you had an if statement, suppose they made an error twice. So suppose they went in there and they typed in -3 the first time. So you're going to print an error message, you're going to reprompt them. And when you give them the second prompt, what if they put in a negative number again? So if you try your program, it's going to check for the first value, but if they put in the wrong value multiple times, it's going to let them get through the second time because your if statement's only going to be executed once. Does anybody else try that? Right, so try your program and put in an invalid power, and then when you prompt again, put in another invalid power and see what happens.
So if you do the if statement, it would just go for one time, but if you do while, it'll keep going?
Exactly, Megan.
Okay.
You get it?
Yeah, I think so.
Okay, for everybody who did that, I get it, because when you read the statement of the problem, it sounds exactly like using an if statement. And the if statement worked, right? The if statement worked if you guys tested it and it did work, that if they put in the value of wrong once, it reprompted and they put it in again. You said, fine, I did like the assignment said. But the difference is that if they did it another time, your second prompt would not have tested it again.
Yeah, basically.
So, okay. So now you see why, not effectively. The only difference then would have been, we'll go back to Nick. So instead of using an if statement, you would have used a while. And here we're testing, when you're doing this validation test, you're testing to see if it's wrong, so I'm testing to see if, in fact, power is less than 0 or power is greater than 50, making it invalid. If that's true, if it was -1, that would be true. If power is -1. And if power was 60, that would be true. So in that case, so now, instead of using the if I use a while, this is going to loop around until the person types in a value greater than or equal to 0 and less than or equal to 50. You guys, Megan, Dan, Katie had the right idea. You just didn't realize, and that's why we're here, that you needed to check forever. And now you've seen that, and now you obviously have the right idea, you just missed sort of by one statement. Everybody get it? Okay. So let's go on to problem 3. So, problem 3 is computing GPA, and and so here for what we need to do is we need to prompt the person for the number of courses they... Question?
Just to go back to for the first, like, instead of doing the while to find the number of problems, could you just do like an if statement?
But if you did an if statement, and you do an if statement to validate it, and let's suppose it's invalid, right, and then you reprompt them, and then they type in another invalid number of problems, what happens?
Cuts the program.
It keeps on going, doesn't it? It doesn't stop them because you're only testing it that one time. The if statement's only going to be executed that one time.
Right. I see what you're saying.
the beauty of the while, Dan, is this test is going to be executed multiple times, and the only when it will stop is when that number is valid. So I don't have to worry about, having 87 tests, because this is just going to loop around until it's valid. That's the beauty of the while statement.
Okay.
And you'll get, I suspect when you write this, the first time you write it, you're going to get the test wrong. You give a test for n problems greater than the number. But once you test it, you're going to get the error message, you say, crap, I'm testing the wrong way, and you're going to go and just change your test to actually test to make sure that testing for is it invalid to get into the loop. I think now, once you've done it using the if, now you're going to realize that you can't, you have to do it with a while. And the reality is anytime you're going to do validation, you're going to use a while. You're never going to use an if statement. The format is going to be almost the same. The test is going to be a little different. It's effectively having the word while instead of if. Okay, so we're going to, person's going to type in the number of courses, and we're going to validate that the number of courses is greater than or equal to 1 and less than or equal to 6. And again, we're using, now that we've gone through this, the idea of validation before, everybody should get this. And then we're going to initialize some values, so we're having a count because we know we're going to have a while loop that's going to go through for the number of courses that they took. And we're going to have total for, I didn't write this in here, I know some students emailed me for what's the calculation for GPA. I guess nowadays the GPA is calculated for you, but the GPA is just a weighted average, so you multiply the credits times the grade, and then add them all up and divide by the total number of credits. I guess I should have put that in there. So we have two variables for the total weights and the total number of credits. And now, because I want to go through for every course, and there could be unlimited, well, there could be 1 in 6 courses, I'm going to use a while loop to test to see if the count is going to be less than the number of courses which they had typed in before. I'm going to prompt them to enter in their grade. And in the first, well, I'm doing it without the extra credit. The extra credit said ensure that the value is an A, B, C, D, or F. So this is not validating it. It's assuming they typed that in. We'll get to that in a minute. And so we're going to enter in a grade. I'm going to convert the grade to uppercase and put it back into grade. So I'm assuming now I've got a letter that's A, B, C, D, or F. I'm going to now prompt them for the credits. I'm going to make sure that the credits are between inclusively 1 and 4 by, again, using a while loop to do validation. I then have to convert the letter grade to a number. So the only way I can do that is by just having a series of ifs and elifs, testing to see if it's equal to an A. Then I'm going to set num grade, which is just the numeric value, to 4. Otherwise, else if it's equal to B, 3s, and so forth and so on. And because I know that it has to be either an A, B, C, D, or F, note that I don't have to test for an F. I just fall into this statement because it's not A, B, C, or D. And so now I can now start doing the calculations. So I'm going to take the numeric grade and multiply it times the number of credits and then add it to total. So I'm getting this running total of the grade, the number grade times the number of credits and putting it in total. And I'm also going to have to add up the total number of credits by simply adding credits to total credits, which I initialized both of these to 0 at the top of my program. And now I'm going to just increment count. So typically, again, sort of when I set up these while loops, I sort of just typically write the framework for the while loop, initializing the while variable, which in this case is count, putting in the while test, and then at the bottom of my loop, putting in the increment, and then filling in the rest of the code because I now know that I have the framework for the while loop. And then once I fall out through this, now all I need to do is to then take the total grade, the total number, the total weighted values, multiply it, divide it by the total number of credits, round it to 3 decimal places, and print it out. Any comments, questions? Again, I've printed out the code for you so you can take a look at it. Nick?
I guess just for the extra credit, I made a list of the individual grades and then did a while the grade was not in that list and just had a simple while function.
Okay, we'll do that in a second. On this, is there any questions on this?
I thought, why do you need the chart there if they're asked to input the number of credits? Like the ifs.
This if statement here?
Yeah.
Okay, so, yeah, so if you, the number of credits is the number of credits in the course, so I could take a 4-credit course or a 3-credit course or a 2-credit course or a 1-credit course. So, okay, you're probably taking, what, 6 courses this semester, all 3 credits, or 5 courses?
Yeah.
But you could have taken 5 3-credit courses and 1 1-credit course, right, for 16 credits?
Right.
So the grade that you get in the 1-credit course,
Yeah, I understand.
get it?
Yeah.
Any other questions? So the one additional complication is we want to validate that, in fact, the grade that the person entered is a valid grade. I said, I'm assuming they're putting in the right grade, but of course, a valid grade, but of course, if I were having people use this, they're going to inadvertently put in a wrong grade, and if they did that, my program would give the wrong answer, and so we've got to validate it they have the right grade. So Nick said what he did is where after, and we could have done this anywhere, but logically we probably want to put it after the grade is entered. Nick said he wanted to validate that grade, and he said, what did you say, Nick?
Well, where you had the count and total credits, I made a list.
Okay, so Nick, correct me if I'm not doing good mind reading here. So Nick created a list of 5 strings, the 5 legal grades. I called them legal grades. I don't know what he called them, but we're using legal grades. And he did that because now he wants to, after he read in the grade, he said if while, go ahead, your cue.
I said while grade not in legal grades, and then I would print the error and resend the input.
Is not, it's just NOT lowercase?
Yeah, not in.
Oh, this is beautiful. So Nick wants to validate that the grade, the letter grade the person typed in was one of A, B, C, D, or F. So again, he's going to use a while loop to do validation. The test is a little different. What he wants to do is grade is the value they typed in and we turned it into uppercase. And he wants to make sure that it is a legal grade, so he set up this list. So he's testing to see if that grade is not, remember that when you're using the in operator, the in operator says, is the value and grade in this list? And if it is, it returns true. He's not interested if it's in the list, he's interested if it's not in the list, in which case it's invalid, and he wants to tell the person to get, and he's going to get another grade. So instead of saying in, he said not in. It's exactly as if you're saying this to yourself, speaking. While the grade is not in legal grades, I've got to reprompt them for it. And so what he does there is, if this test is true, I know it seems a little backwards, take a second to look at it. If this test is true, it means it's not a grade in legal grades, meaning it's invalid. And what he did is, perhaps he said, print, error, invalid grade, and he might have said re-enter. He could have put this all in one statement. Oh, instead of actually saying print, he could have said grade equal input. So he prints out an error message and he reprompts them for it. That puts a value in grade, and he does need to put it in uppercase, and so after that he's also going to put that in uppercase, and that's going to be my validation loop. So I'm going to go back there, and they're going to get another crack at putting in a grade, and we're going to test to make sure it's a legal grade. If it's not a legal grade, then this test is true, and they get back another error message, and they're not getting out of that loop until they put in a legal grade, A, B, C, D, or F. Everybody get it? Anybody else do it a different way? I did it a little different. If you recall, the in operator works exactly the same way for strings as it does for lists. So the way I did it, and the one that I handed out, I actually didn't have a variable legal grades. I actually liked Nick's better. Instead, I had the constant here. So it's still going to work. This is a string, and it's now saying don't look in a list because I'm asking you to look on is a string. So it's going to say is grade in the string A, B, C, D, or F. It's the same thing that Nick did. I just used a string as what I'm comparing it to instead of a list. And I didn't create another variable. I could have created a variable legal grades as a string instead of a list, and I just typed it in as a constant. Any other questions? Okay, if you guys did this in an hour, that's good. Okay, so I want to do one new idea and then do one more problem. So one small idea, we actually saw it before. You don't like it, you don't want to use it, that's fine, but it's sort of a nice addition into the Python. So here's the new idea. I did show you this very briefly before because some student had used it and I wanted to, I went through it, but let's go through it again. So if you recall, I had a while statement. Let me go back to my, right. So let's take a look at this code. So I had this while statement where I'm testing to see if power is less than 0 or if power is greater than 50. So I have two comparisons there. One, see if power is less than 0 or if power is greater than 50. And it's combined together with an OR. It turns out that Python has a nice simple facility for making two tests without having to repeat the variable or the word or. So I could have instead used this idea. So instead of having two tests with power, I could have instead, sort of like mathematical notation, I could have said if 1 is less than power less than or equal to 50. So what this really says here is power greater than or equal to 1 and less than or equal to 50. If that's what you want to see, if you want to see if a number is within a range, and here it's inclusive, so I have less than or equal and greater, have less than or equal twice. So this says this is the equivalent, this is the exact same thing as saying power greater than or equal to 1 and power less than or equal to 50. So this, if you want to do this, another way to express it, if you like, is by doing it this way. If you want to do it this way, that's fine. But you might see Python code that does this. And of course, because when you're doing testing for validation, you want to see if it's not within this range. I prefix it by the word not, which says, so this says, is it in the range? And I'm testing to see if it's not in the range. That's why I prefix it with not. But the important point is that this is the equivalent of that. And if you're not comfortable using this, you think this way, that's fine also. But it is a facility within Python. Okay, so for the rest of the class, I just want to reinforce some stuff with while and do another problem with while, because I think it's one of the harder ideas in programming. And so, as we had a discussion earlier today, in doing comparison of while and if is a statement that will perform a test once and perform a true action or a false action once. So if I want to do if I want to test a condition and to do two different sets of actions, an if statement is fine. The while statement also does a test, but that test can be performed multiple times, and it's used for not picking out doing one thing or another, but it's really used for having a set of code that's executed multiple times, and the number of times that it's executed is based upon the test. So the if statement in computer GEs is called a branching statement. It allows me to go to one section of code or the other. The while statement really is used for repeating code over and over and over again. And the while statement, as we've seen, can be used in a variety of cases. It can be used for validation, which we explored today. Its basic use is for repeating statements multiple times, and a lot of things that we do in terms of repeating statements is getting running totals. And by running totals, I mean what we did today for the GPA, where we're constantly adding up credits each time through the loop, and we're adding up that weighted value, the credits times the grades. That was a running total. So while loops are very useful for facilitating us creating running totals. And that's what we use a while statement for. The hard part about programming is looking at a problem and figure out, hey, I could do that by repeating statements multiple times. Even in the while statement, we might have an if, or what you saw, what I didn't point out is, I sort of snuck by, which I thought people might be upset at, but apparently not. Note here, and this was perfectly natural, that we had one while statement embedded in another while statement. And if the problem called for it, could we have had a while statement embedded in this while statement? Yeah. It doesn't really care, and it makes a lot of sense here, because this while statement was doing validation. This while statement was doing controlling the number of times that the loop was executed. So the while statement, in particular, sort of addresses multiple situations that we encounter when we're writing programs. Of course, we could be creative when we're using it for things that don't fit into these buckets. That's fine. It just turns out that the while statement does fit into these buckets very nicely. So let's try to do another problem. And I'm going to give you guys 10 minutes to try to do this problem, and then we're going to go through this problem and see how to solve it, or my solution to solving it. So let's do the following. Let's try to write the following program. We'll prompt the user to enter in. We're going to be calculating the value of investment in the future. And so we're going to prompt the person to enter in an annual interest rate. We're going to prompt the person to type in a principal amount. And we're going to prompt the person to type in a date in the future. Where the date in the future, we're going to stipulate that they're going to enter in as month/day//year/year. So for today, they would enter in 10/09/2019. And what I want the program to do is to calculate what that principal amount is going to be. So a person would type in, for example, they would type in for annual interest rate, well, let's do something realistic. 1.61, sort of the interest rate on short-term treasury notes now. They would type in a principal amount of $10,000. Let's say 1.5. Let's do it something simple. So they type in an interest rate of 1.5. They type in a principal amount of $10,000, and they type out a date in the future. Let's say March 1st, 2020. What the program should do is it should calculate what that $10,000 will be on March 1st, 2020, if there was an annual interest rate of 1.5. Compounding daily. So what does compounding daily mean? Anik? What does that mean, compound daily?
Every day. That's all.
And how's that different than just regular compounding? Regular interest rate. So if I said, I'm going to...
Does the interest rate apply the day before, not from the beginning?
The same interest rate. But if I said, I'm going to give you, you give me $10,000, and at the end of a year, I'll give you $10,000, and I'll give you an interest rate of 5%, but it's not going to be compounded daily, it's going to be compounded annually. And somebody else said they're going to give it compounded daily, which one would you get? Because?
You get more every, builds up more.
Why does it build up more?
Because it takes the compounded one from the one that was
The day
also
before.
compounded.
Right.
Yeah.
So if I compound it, if I were to give you, if I gave you 5% annually, it'd be $10,000 times 5%. So you would get 5% of 10,000 is $500. So you would get $10,500. If it's compounded daily, what that says is we're going to calculate what the interest. Let's suppose it's 5%. What the interest rate is daily. So it's not 5% daily. What would you get daily for the interest rate? You get, Dan?
5% divided by 365.
Correct. And then you take the $10,000 and multiply it times that, and then the next day you take $10,000. Now it's not $10,000; it's $10,000 plus a little more. But now we're calculating the interest not just on $10,000, but the $10,000 plus the interest. That's what the compounding means. You're getting interest on interest. And the weird part is, do this calculation. So it sounds like, oh crap, if you do the calculation of like 5%, which you're not getting 5% nowadays, you're getting maybe 2% at a bank. But if you look at how there's this notion of the power of compounding, if you see how compounding actually adds up over a period of time, it really makes a difference. So in this particular case, what you're doing is you're calculating what this principal amount is going to be compounded daily. So what's that going to be sometime in the future? For our purposes, we can assume the following. Let's just assume there's only 360 days in the year. It's going to make it easier. And that every month has 30 days. You're going to see why that's important. and assume that the interest rate, that the interest payment starts today, so you put the money in the bank today, and you can print, I don't care about, you can print out the answer to 2 decimal precision. This is a hard problem. If someone gets this in 10 minutes, that's pretty good. Okay? So once you guys think about this, so here's, the interactions can be fairly straightforward. Interest rate, let's do 5%. It's going to be easier to do that. I think I did it. And you're going to put in $20,000 as the principal, and then you're going to say that the future date is March 1st, 2020, and you're going to print this out. This is what the output's going to be. But you've got to compute what this value is. So why don't you take some time and see if you can come up with some ideas. We're going to go through this solution. Again, I don't expect people to get this in 10 minutes, but I want you to sort of think about what problems you've encountered when you try to solve the problem. You don't have to validate the numbers. You just assume they're putting in reasonable numbers.
go?
Actually, you just went through that. Is there somebody saying?
No, but I need two.
Yeah, you gave me two.
Oh, you gave me three. I'm sorry?
What are our exams going to be ungraded by?
The first exam?
Yeah.
The grade.
Okay. Can you give me some example numbers to encode it to? Okay.
I think that's the right answer.
Okay. Is that 5%?
Yeah.
Okay. Oh, so when they do the input for the future date, it has to be in that same exact format?
Correct.
Okay.
Month slash day slash year. You can assume that they will do that.
Okay. Sir, can I see those numbers in the time?
Mhm. That should be enough. Okay, so anybody get it?
I'm really close.
So, okay, I really, really don't feel bad if you didn't. I didn't expect you to. It's a lot to ask. It's a big ask, and there's one part of it I suspect you have no idea how to get. But I want to go through, okay, so here's my point here. So my point here is I want to go through sort of a thought pattern for those people sort of clueless how to do it, or people that sort of have an idea. What I want to talk about is how you would attack a problem like this, okay? How do, you know, what inspiration would you get to solve it? And if you're completely clueless, the way I would solve this, okay, a method of solving things is to take the problem and make it easier and solve the easier problem. So you look at this and say, okay, I'm reading this thing, crap, this is hard. How do I know, you know, fine, I get the idea of compounding and I'm getting interest every day. But how do I know how many days there are between now and March 1st, 2020? I have no idea how to compute that. So I would say in solving that, trying to solve this problem, say, you know what, I want to forget that. Let's forget that constraint and let's just say, what would be the amount of the investment tomorrow? Would I be able to calculate if I knew it was just one day instead of however many days, which I don't know? So let's solve the problem for one day. And so I would go through and I prompt the person for the values, okay, everybody watch, and I'm getting the values here, there's nothing new here. And then, because I'm doing it daily, I should figure out, well, the rate is a whole number, but I've got to convert that into first a percentage, you know, a decimal number. So I'd say, I'm doing this more, I would say rate divided by 100. That gets it from 5 to 0.05, right? And then I want to know what it is daily. And I did this in two separate statements. Let's do it this way. So now let's take the rate and divide it by 360 because I said there were 360 days in the year. So this puts it in, it makes it a decimal number, and this makes it into the rate per day. Everybody with me so far? And now I said, let's solve the problem. So what would that principle be if I said, how much would that principle be if you had if you were just computing the interest rate for one day? What would be the formula? Somebody. If I told you had $10,000 now, and let's suppose you're getting 5% today, it's the most fabulous investment ever. what would be the formula for calculating what it's going to be, what that value is going to be for 1 day at 5% at $10,000? What's the formula? How would you do in your head? I said, okay, let me do it this way. Suppose you're now making $20 an hour and you're going to get a 5% raise. How much are you going to be making? How much are you making after the 5% raise?
Just do 20 times 1.05.
It'd be 20 times 1.05. So it would be, in this case, the 20 is the principal times 1 plus the rate, right? So if the rate were 5%, this would be 1.05, and that's going to give me, right? So if I were making, let's instead of doing it an interest rate, let's suppose it's my pay, and I'm getting $20 an hour, and I'm getting a 5% raise, so this would take 20 times 1.05 to give me 21, right? So after I do this calculation, this tells me how much my investment is after 1 day. Hold on, I'm on a roll here. Everybody get that? Okay, suppose I now, so I just solved the problem for 1 day. I can go home now, have lunch, I'm hungry. If I said to you, change this program now so that you could tell me what the value of it would be after 2 days, what would you do to this program? Simply. How would you change this program? This does it for 1 day. How do I change it to give me the value for 2 days? It's a simple answer. Don't overthink this. This did the calculation for 1 day. How could I do it for 2 days? If this told me what it was for 1 day, how could I calculate it for 2? Right, because now this told me what it was for 1 day. So principal now represents the value after 1 day of interest. This gives me for 2 days interest. How would I do for 3? I could just copy it again, right? So this formula really computes for me for 1 day what the new amount is going to be. I just solved the simpler problem. I'm able to do it for 1 day or 2 days or 3 days. Okay, everybody. How would I change this? Now, I don't want to keep on copying it. Suppose I said it were 50 days. What would I do to this program to compute what the value would be after 50 days? What statement would I use to do this calculation for 50 days? So instead of copying this over and over again, the while statement allows me to do copying, right? So I can say while, and I have to create Now I'm going to repeat that principal statement not 1 time or 2 times or 3 times. I'm doing it 50 times, right? I'm getting to it. Okay, so what I'm trying to do, guys, here is, I understand this is hard to do and trying to come up with an idea on how to solve problems. What I'm trying to motivate here is how you can come about it if you're completely lost. And the key here is solve a simpler case. So instead of trying to figure out how many days, that's hard to do. I don't know how to calculate the number of days. Okay, let's forget let's forget the problem of the number of days. Let's just do it for a fixed number of days, and we can worry about that later. And so if I can solve it for a fixed number of days, which I just did, now I've solved the problem. Now I've created another problem, figure out how do I calculate the number of days. But now at least I have, if I knew the number of days, if I could magically tell you the number of days, and let's suppose, what would you need to do to change that? All you'd need to do to change it, it'd be to change 50 to, if not, the variable number of days were the number of days between today and March 1st, 2020, that's the end of the program. Have a nice day. We're done. So in attacking problems like this, if you're lost on how to solve it, make a simpler one and solve that. You get it? And now that I've done this, okay, fine, I'm great. Now I've solved a large part of it. Now I can walk away and I can say, okay, how am I going to figure out the number of days? That's a hard problem. You guys would not know how to do it. When you see the solution, you can say, oh, that was pretty simple. But having not seen it before, let me restate that. You're not getting it in 10 minutes. Perhaps if you went back home for a day and thought about it and came back, you might come up with an idea. When I show you the idea, you're going to say it's fairly simple. But the important part is to break the problem down into something simpler and then now work on that other hard part. And it could be there could have been a number of different harder parts, and let's get rid of the hard parts and let's solve something simple. After you do that, then let's attack the harder part in isolation. So now I'm going to now try to figure out the number of days. Okay, so you're going to say, gee, that was simple. So anybody know what a Julian date is? It's very simple. So you look at a calendar. Today is, what the hell? Today is October 9th, 2019. It turns out that you can also count the calendar by what day of the year it is as a number. So January 1st is always number 1. January 31st is the 31st day in the year. February 1st is the 32nd day of the year, right? And December 31st is, depending upon the year, either the 365th day or the 366th day. It's known as a Julian date. So the way you solve these date problems is as follows. So today, let's just suppose today is equal to, I'm going to put this in this form, it's 10:09. If I could convert today into a Julian date, a number, and if I could convert the future date into a Julian date, then if I subtracted the two, that would be the number of days. So let's take, so whether we can do that is, this is Julian dates within the year. I'm going to add, is the day within the year. So what I'm going to do is I'm going to say MM, let me just type this, nervous. Did you do this, Jordan? Break it down this way?
Yeah.
Very good. So what I've just done here is I've taken today, which is in this string, and I've extracted out of it the month, which are the first two characters, and I've converted that into a number, the day, which are the index 3 through 4, and then the year, which is 6, right? So that's 0, 1, 2, 3, 4, 5, 6. I'm taking 6 to the end of the year. So after this code gets done, MM is equal to 10, DD is equal to 9, and YY is equal to 2009. So to convert that date into a Julian date, okay, if I forget about the year, all I'm doing is I'm taking the month, and I said that there were 30, I said in the problem is 30 days per month. And so I'm taking the month number, so if the month number were 10, as it is, what I want to do is take 9, because there have been 9 months so far, January through September, and I want to multiply that times 30. I'm not going to do it by 10 because we're not finished with October, but I want to enter in the day of the year, of the month it is, so I'm entering in DD, the day of the month. And then I said there were 360 days in the year, so I'm going to take the number of years and multiply it times 360. This effectively gives me the Julian date actually since the year 00. Since the year 0. So that gives me a number, right? It gives me the Julian date. And now what am I going to do next, everybody? So now I got the Julian date for today. What am I going to do next? Just do the future date. Effectively, I copy this code. And I'm going to substitute future date for today. And that gives me the Julian future date. Right? And now what am I going to do? Katie?
You're gonna make number of days to be equal to Julian future date minus the Julian today.
Perfect. And the problem solved. Yeah, I'm sure.
There's a space between Julian and Date.
Oh, I didn't print it out, you moron. Okay. And that's a... Oh, what did I do wrong? I violated my own coding rule. So what I had there was wrong, and I didn't round it to decimal places.
Maybe count had to be 0 instead of 1 to start off.
What? No, because I had less than or equal to, so that's right.
Okay, so it's less.
Did you get that number?
Yeah, I got that number at first, and I switched around my count a bit. But I got 20,401.
Which is what I had on the slide, I thought. Yeah. So I might have done that wrong. I think this one's right. But, okay, so everybody in the class, I think this one's right.
Okay.
I think So everybody get this? And I sort of did this from scratch. I sort of thought about the problem before, but I really like this idea of solving. Look, if you looked at, first of all, two things. This date idea you're now going to remember. It's a fairly simple idea. It's straightforward to convert a date into a number, and now you can do date arithmetic. Now that it's a number. So that's pretty straightforward. But I really do like this idea of taking a problem and making it simpler. If you're stumped, if you're not stumped, if you sort of have an idea, then just go for it. I'm fine with that. The purpose of this lecture today was, if you're stumped, what sort of tactics can you use to try to solve? Throwing up your hands is not the way you're going to do this. But you guys know enough, and it seems like you guys, especially if you did today's homework in an hour, you guys know enough to start fiddling around with it. And what happens is, if you get something running, it makes it easier then to modify it to then get it right. It's almost like, don't you hate when you have to write an essay to start off? Don't you love it if you would just have like 3 pages of crappy stuff that you wrote down, stream of consciousness, you had to edit it? It's so much easier to do that. If you have some code written, it's so much easier to modify it to put these additional things in. And you don't want to clutter your mind up with trying to solve the whole problem. Let's take parts of it. The problems are going to get harder as we go along, and so you're going to have to use that idea. So, okay, so no class on Monday. Have a nice break. I handed out an assignment. We're going to do more of the while statements. Very good, Jordan, for getting this. And have a nice break.